Hi, I'm Mark for ACLS Certification Institute, and in today's program we're going to talk about drug calculations, how to draw up correctly and administer the proper dose of medications to your patients. Now, first, let's take a look at the drug packaging. First, you're going to have the name of the drug. Very helpful. Second, you're going to have the total amount of drug in that container. Then, you're going to have the total amount of fluid that's in that container. And then you're going to have the concentration. And the concentration is how much drug per cc in that container. And you're going to need to know all of these so that we can accurately calculate and administer our drugs. Seems about every 8 minutes in EMS, someone's coming up with a new acronym, a new mnemonic, flip chart, field guide, something scribbled on a cocktail napkin with a formula so we can remember how to do stuff. And formulas are great. And I'm going to share with you today some formulas that I learned for calculating medications. For simple injectables, for one-time shots, remember the formula: give divided by half times cc's in the vial equals cc's administered. Well, let's break that down a little bit. Give divided by half. Give. I'm talking about give. I'm talking about how much drug do I want to administer to that patient. And that's the dose. The dose is how much drug we're giving the patient. Not how many cc's, but how much drug are we administering to the patient. So how much drug do I want to give? Divide that by how much drug do I have? What's the total amount of drugs in this vial? So give divided by half times cc's in the vial. And that remains constant. Even if you start drawing fluid or medication out of that vial, the number of cc's in that vial remains the same because that's the concentration. So for example, if you have 4 milligrams in 2 cc's and you pull out a cc, it's still 2 cc's. You don't subtract that amount. So whatever's on the vial, whatever's written on the vial, that remains constant throughout the administration of the drug, or repeat administration of that drug. So remember, give divided by half times cc in the vial equals the amount of cc's we draw up to administer that dose. So let's take a look at that. Let's run through a practice here. Let's say we have a patient, we've worked him, we've resuscitated him, but now he's going to need some sedation. So I have some Valium here, and I have 10 milligrams in 2 mLs. Gives me the total amount of drug, which is 10 milligrams, the total amount of fluid, which is 2 mLs, and it also gives me the concentration, which is 5 milligrams per ml. So the doctor says, okay, give him 4 of Valium. Okay, 4 of Valium. How much do I want to give the patient? I want to give the patient 4 milligrams. That's the dose of medication. I'm going to divide that by how much drug do I have, which is 10 milligrams. So 4 divided by 10 equals 0.4. Then I take that 0.4 and I multiply it by the number of cc's in this vial, which is 2. That gives me 0.8. That means that I'm going to draw up 0.8 mLs to administer that 4 milligrams of Valium. So let's do some practice for a minute. Let's use that formula, give divided by half times cc in the vial. I'm going to give you some drug orders. You can go ahead and work up the problem and see if you get the right answer. Let's talk about calculating for medication infusions now. And I'll use the example of dopamine. Now, The first thing we have to calculate for, figure out, is our concentration. And you want it to be your dosing concentration, your working concentration. Now, we all know the starting dose of dopamine for heart failure is about 5 mics per kilogram per minute. This bag's going to come 400 milligrams in 250, but I'm dosing in micrograms. So I need my concentration in micrograms. Now, I can simply look it up on the package and it gives me that, 1600 mics per ml. That's my concentration. If this wasn't on here, I could still figure it out. I just take my 400 milligrams, divide it by 250. That gives me 1.6 milligrams per ml, but I'm dosing in micrograms. So I have to have the same dosing parameters. I need to know my concentration and what I'm dosing in, and in this case, it's micrograms. So I multiply that 1.6 by 1,000, and I get my 1600 mics per cc, per ml. That's the first thing you have to calculate for. What is my working concentration? Then for dopamine, simply over that, write down what you want. What do you want to administer to the patient? I want to give 5 mics per kilogram per minute. We'll say the patient weighs 70 kilograms. So simply write that down. 5 times 70 times 60, because it's per minute, divide that by my concentration, which is 1600, and that will equal my mLs per hour. All infusion pumps are set ultimately to administer mLs per hour. That's what we're calculating for. How many mLs per hour am I going to administer to achieve that dose of 5 mics per kilogram per minute? So let's say we're going to start a 10 mic drip. Patient weighs 80 kilograms. Okay, 10 times 80 times 60 divided by my concentration equals mLs per hour. Now here's a nifty little trick. Let's say that the drug isn't weight-based, it's just per minute. Take that part out, same formula. Okay, so using this method, let's calculate up some different dopamine drips. Again, I'll give you a dosing parameter from the doctor. Pause the video if you need to while you're working on your answer. Let's work on a couple of problems. Now, drug preparations come in all different kinds of sizes and packaging, but one I want to focus on right now is called a CarpoJet. And if you're not familiar with these, let me just go through and show you how these guys work. Now, a CarpoJet is a pre-filled syringe, and it's designed to go into this actuator. You slide this in, and this little white part's going to fit into this groove here. Now, how you activate the CarpoJet, you're going to screw in the bottom, and by turning this lever at the bottom and locking it in, what that does is it pulls this white tab into the vial. There's a small needle inside here that punctures a little membrane and allows the drug to be administered. But what has to happen is this white part has to be pushed down to actuate, get that needle inside the vial so we can administer the medications. To remove it, simply unlock it, unscrew it, and the whole thing will pop out. Now, I'm not a math whiz. I have a calculator watch on my wrist for a reason. We have to use technology, and in some of these bigger calculations, especially with multiple drips, you want to double check your work, which means you're going to have a calculator. Make sure you have the right drug, the right patient, the right route, the right time, the right documentation, and have someone else double check your work. Seriously, is this Versed? Oh, it's Vecuronium? Yikes. Double check your medications. Don't be afraid to ask. Have someone physically look and double check that medication before you administer it. I hope these formulas helped. Hope you had a good time. I'm Mark for ACLS Certification Institute, and I'll see you in the next video.